All right, next up we got James Fourman, and he's going to be talking about computational system federation through the common service. Oh, common service bus. All right.
Well, thanks, Mike, for the introduction. Appreciate it. Okay, so thanks for all coming out to the computational system federation through a common service bus. You heard a little bit about this earlier from Matt when this is this morning's presentation. So, yeah, how many are the developers in the crowd besides AFRL? A couple. So how many of you actually have had many issues connecting to other systems besides your own, trying to flesh out an API, keeping it common in this case, and getting frustrated along the way as you're like, what are they doing? Why are they doing that, etc. So keeping that in mind as I go through this, we'll kind of try to give reasons why we made a common service bus to kind of, hammer that out. So I'll go over what exactly is the common service bus for our definition, why it's beneficial, or at least why we think it's beneficial, kind of how we implemented it in our application, some of our successes that we had with it, and then where we see ourselves going. First, this is the copied acknowledgement slide from Matt before, just giving thanks to Dr. Ward, Dr. Benedict, who is not here, and our development team plus HUBzero, because they are intricate to our actual process. So what exactly is a common service bus? It is based on the service-oriented architecture. We use a lot of RESTful API services to connect from one system to the other. That is our base and our building block. From before, Matt did mention this, we broker all the transactions. We say, okay, you're system A, you want to talk to system B, okay, we'll do that. And all you have to do is, okay, this is where I want to go, and it'll actually put you there. And when it comes back, you know how the actual data is returned. It's all standard. We also like having this in kind of the middle to control the versioning. We're kind of in that middle. So you may be talking to version 1 of our API, but they're maybe on version 3. So you don't have to worry about always changing your software to keep up with them. And this helps keep with the federated architecture that Matt mentioned before, because we have a lot of systems that are out there. I don't want to put them in there as lead developer. I don't want to consume everybody and put them in our application, so I like having everybody do what they do best. So with that, this helps us talk to every system so that it keeps everybody happy in communication. So we mentioned before that we're using Django as our development platform for some of our applications outside the hub. And with that, through an extension, Django REST framework is what really allows us to do all this RESTful API work. So what it does is allows us to accept multiple data formats. We're not stuck with just XML, we're not stuck with just JSON, even though those are the most popular. You can actually send in text and HTML to this, and it will read it, as long as it's formatted in a way that it understands. Now, when it returns the data, all the types of you see up there, JSON, XML, HTML, text, YAML, that's what can be returned. You don't have to be specifically returning JSON each time. It's your choice. And when we're going through, as we develop our actual endpoints, the versioning is a beneficial because it's already built into Django REST framework. I don't have to build something in there to figure that out. And like I said before, this is how we're enabling our federated architecture. This is how we're doing the brokering. So without a common service bus, as we mentioned before, when you need to talk to your systems, you need to know how to talk to each system that you want to actually go to. So in this example, I have 6, but Matt mentioned before, we have about 12 to 14. There's a lot of systems that we have to talk to. And each one of those systems would have to know how to talk to each other. And we can't guarantee that, say, Grant, as we mentioned before, will know how to talk to Plotly. We'd have to pay them, they'd have to do development and change it over. So with that in the system, talked to Jason about giving me a nice formula of how many connections would actually be there as you increase systems. So when we grow, we may be up to 100 or so systems. With that, as a total connections, that is 4,950 connection points you'd have to make. That's a lot. I don't want to have to do that. That's only 100 systems. Now let's talk about our lovely multiple instance insanity. We may need to talk to the Army Research Lab, the Naval Research Lab, and they may have 100 systems each or more. So in that 300 systems, that's a lot of connections. I don't even want to have to try to calculate that. That is way too many I want to have to work with. So with our approach, we have, once we put the common service bus right in the middle, you have reduced that down to only the number of systems in there equals your connections. So we only have 14 connections that we have to worry about. Or in our big, once we get to the end or so, 100 systems or so, that's not so bad. 300 systems, okay, 300 connection points, not so bad, but when you talk about going into the multiple instances, that 300 actually comes down to 3. We want to have a common service bus talk to common service bus, talk to common service bus. They should know how to talk to each other, bring it down into its system-to-system brokerage. And all I need to know is how to talk to the Navy. I don't need to know how to talk to each one of their systems inside the Navy. Just need to know how to route to it. So we saw this before. Again, you don't have to read exactly what's on there because I know it's hard to. But there's a lot of systems in here. So I'm using this as an example to kind of bring back Matt's third case study of what happens when you want to do a search. And this is why the common service bus is so key. First you're going to put your search terms into a plugin on the hub. Say this is, for titanium, I want to find Young's modulus. I think we used that before. So you're going to call the common service bus with the PID search and all your parameters. It's going to go ahead and find all the metadata associated to it and where it lives. And then it's going to come back to the common service bus, find out where it needs to go, and then it's going to return the data back to you and how you requested it. In this way, it's probably going to be you'll have a list of, all these systems have actual Young's modulus. Let's go click on it, and maybe it's the data you want to do some plotting, and maybe you want to go plotly with that. Maybe you want to use Enrapture. I'm not sure how we'll go with that. The key takeaway, I'm going to go back here to, if you didn't have the common service bus sitting in the middle and you're in the hub, first you have to say, okay, search. Now you need to go through Plotly and search. Now you have to go to Granta and search. Now you have to go through your file ingestion and see if it has logs that maybe had something, your DMS, your files plugin. You don't know where the data is going to be. You'd have to search everything in your repository, and it would take a very long time. And I don't think anybody wants to have to do that. So that's why we believe this is very beneficial. So the common service bus was the core for ICE as we were developing it. As Matt said before, we were kind of driving in the car and thinking, hey, how can we get these systems to kind of talk to each other? Well, we said, okay, let's build an API. Well, actually, let's build our software on the API and not have to worry about trying to put it there after the fact. So when you're doing something like that, you do come up with some challenges of, well, I need to make sure that whatever I develop is as easy for me as it is for everybody else. And that's not actually as easy as it sounds. But with our hub integration, we showed the data forms earlier in Matt's slide. We'll be showing the visualization tool with Jason T's coming up here later. Equipment integration, which was the testing framework, and possibly the output of our testing equipment may not be from the other software. It may just be a straight, just exporting out to our software. We'll read it in and throw it up in Plotly, if that's what you want to do. In order to kind of help with the common service bus and keep everything going together, for authentication reasons, we're using OpenID Connect. Now, Kevin will be talking more in depth about this here in just a little bit, but it does help keep our transactions secure so that we don't have to worry about when we're transferring the data. We also talked about it was JSON web token that helps with keeping that encryption going back and forth and keeping it secure. And with this, the common service bus and OpenID Connect, I don't need to store all my login information for every system that's out there. And we'd have to develop in the hub 100 connections. And each one may have different identity matrix that we'd have to keep going back and forth, which we would really rather just use the CAC to go back and forth. And then our persistent identification, our identification integration helps with that whole searching that you saw before. I don't need to know in the common service bus where things live. I'm relying on Ontology Metaverse and the PID server to tell me where those things are. Once I get that, I'll go find it, go to that system, retrieve the data, and return it back to the user who called it. So for the next steps that we're going to be doing here in our software, we talked about multiple CSV integration. We are going to be doing that here soon. I'm not sure exactly time frame, but it is coming up pretty soon, I do believe. We want to keep maturing the tool. We want to keep adding systems in there, adding, as Matt said before, we want to be able to hand you different ideas like workflow or DMS or whatever you want to choose. Common Service Bus will come along with it, but you don't have to use any of the rest of it. Just use what you need. We want to make it available as open source, so you guys can download it, install it at your leisure. And we would love to hear from anybody who actually wants to collaborate us to help either mature a tool, add suggestions that you guys might have or anything. And I put Matt's email up there because he's the easiest to get a hold of, and he will route the questions directly to us. And does anybody have any questions?
Question? Well, I have one. So I was trying to figure out when you have this, if you shot out on the Common Service Bus a search request, if there are multiple things out there that can all implement it, they all shout back?
We'll go to the PID server and the Ontology Metaverse to figure out who needs to shout back to you.
So there's always one response. There's not multiple.
You shouldn't have to have multiple responses, because I think that would start crowding, and you'll get a lot of information back.
Well, because when you mentioned the search case, I thought it was interesting, because that's a case where you really do want multiple responses back.
That is true. So if the Metaverse came back and said, hey, you have 5 systems that have your data, it will come back actually from all 5 systems. It's not just one system it goes to and says, okay, this is what we think you need. No, it'll do all 5.
But it'll tell you what to expect back, because my next question was going to be, like, once you shout out, how do you know how long to wait for the responses? So you know you're going to get 5 back.
Yes. We'll have to, I don't think we have that in the tool as it is right now, but that is definitely something we'll have to think about.
Yeah, okay.
Because it could take a long time.
Well, because that's the tricky part when you're doing those kinds of things, because you know, in a asynchronous programming model like that, you throw out a query, and then the GUI usually waits for things to come back, and then as they come back, it populates like results and stuff, but you never know like when you're done. Like sometimes the user moves on to the next task, and then wait, I got another search result for you. You're like, never mind, right? Yeah.
Okay, it'll be something we'll have to take note of.
Yeah, cool. I like that idea. The Common Service Bus idea is a great idea, because when you have complicated systems like that, that's the only way to mediate the communication.
Yes.
We used to do that on CAD tools when I worked at Cadence the same way. Then we had a lot of things that plugged into the bus to send messages. But the distributed programming problems were, the sort of the asynchronous programming problems were always the interesting ones when you get things that you didn't expect as results.